Okay, let's do the first derivative. And we have an interval here between minus pi over 6 and pi over 2. So let's write this down. So f prime, I'm going to claim it's a product. It's not claim it's a product. And I'm going to leave the first function alone. Right, that's e to the minus 3x times the derivative of cosine, which is minus sine. Let me put that in the beginning of 3x, and then times the inside's derivative of 3x, which would just be 3. All right, let me go to the next thing. Is going to be the derivative of the first now. So it's plus the derivative of the first, which is actually just minus 3, e to the minus 3x, and then cosine of 3x. I'm going to simplify it, and the way to simplify it is just simply to factor it, and you get f prime. And I'm going to factor out a minus 3. I'm going to factor out e to the minus 3x as well. All right, let's see what you get in the first term. You get sine 3x plus, I'm going to factor out minus 3 and e to the minus 3x. I get cosine 3x. All right, so I'm looking at this thing over here, and this is a derivative. Certainly I'd like to check it, and I check it with the key. It's right over here. That looks fine. Now I got to find the critical points, and the critical points are going to be on this interval over here. So let me take a look at it. And before I do that, I want to point out, certainly I'm going to talk degree just for a few minutes here. It's going to be 180 degrees over pi. Pi's cancel. 6 goes in 180 30-degree times. So minus 30 degrees. Let's do pi over 2. Again, you probably should know it, but let's just go through that. 180 degrees over pi, and that would give you 90 degrees. So our analysis is going to take place between minus 30 degrees and 90 degrees. Now again, we should be speaking in radian, so that's going to be minus pi over 6, and it's going to be pi over 2. Oops, I shouldn't put an arrow there. Let me erase pi over 2. Now the question becomes is when is the derivative equal to 0? It's defined everywhere, by the way, in that interval. So what do? I look at this, and this becomes 0. Let's write this down. So it'd be sine of 3x would have to equal the opposite of the cosine of 3x. Let's take a look. So I probably like maybe divide both sides by cosine, and you would get, tan of 3x. And again, I divide it by cosine of 3x, so this would be minus 1. So what I want to do is talk about, what it looks like as if this was a theta problem. And I'll write this over here. Tan theta is equal to minus 1. That's a relatively simple problem. Theta would be minus pi over 4 plus pi k. All right? Now, if you want to use degrees, which I think is not such a bad idea, it's minus 45 degrees plus 180 degree k. But I don't want theta, I want x. So what do I know? I know 3x is equal to minus 45 degrees plus 180 degree k. All right? Divide both sides by 3, and you get x equals minus 15 degrees plus, 3 goes in 180, 60 degree times. Right, this allows me to, put critical numbers down here, and it certainly, I'm going to speak degrees, but I do have to translate it back to radian. So what do you get? If k is, I guess you could take k to be 0, you get minus 15 degrees. Put this over here. Right, and then if I took k to be 1, I get 45 degrees. If I took k to be 2, that would be 120, but minus 15, it's not below 90. So I think I'm okay. All right, I think I'm okay. So what do you do now? And I guess I should write down the radian measure of this. This is pi over 4. And this is minus pi over 12. If you need help with that, minus 15 degrees times pi over 180 degrees. You certainly get a negative number. You certainly get pi on top. 15 goes in 180 12 times. 10 times 15 is 150, and 2 times 15 is 30, and 150 and 30 is 180. All right? So what do you do now? You test the waters out. And so what do you test them out? And the place you test them out is in a derivative. This is the derivative over here. So I'm going to pick numbers that I think are going to be pretty easy to deal with. And the one number I want to pick over here is just simply 0 degrees. I think it's really easy to choose that. All right. So if I chose that number and plugged it in over here, what are you going to get? You're going to get a negative number, which means the function's decreasing there. Now I want to go over here and also want to pick a very easy number, like 60 degrees. All right. Now if you chose 60 degrees, what would you get? So be careful about this. We get, let me write it down for you. The 0 is very easy, by the way. If I'm testing 60 degrees out, I would get minus 3e. Avoid the temptation of writing down, minus 3 times 60 degrees. It's actually minus 3 times, 60 degrees would be pi over 3. So it's just going to be minus pi. Sorry about that. I'm going to get my eraser out. Again, we're testing 60 out. So I get a negative number, and e to that minus pi is still it's still a positive number. I'm not too worried about that. And then I gotta again, I'm not concerned about the number. I'm just concerned about what's the sign of it. And I'm looking at this, and it's going to be the sign of 3 times 60, and 3 times 60 is 180, and the sign of 180 is going to be 0. So I'll just put the 0 there. Again, I'm trying to care about the sign. And then what do I get? I get the cosine of 180. And the cosine of 180 is a negative number. So it's minus 1. So which is going to be positive? That goes up. All right? So I'm going to start to erase things. I think I can erase this business over here. And what I want to do is I want to go below minus 15 degrees, but I want to be above minus 30. So I'm wondering what to choose here. And I want to choose a number, I'm going to say minus 20 degrees. All right? That's between minus 15 and minus 30. Now again, I want to point out the beginning of it is minus 3e to some power. And that's it, e to any power is going to be positive. So I definitely get a negative 3 there times something. It's just a negative. When I say times something, e to the minus 3, regardless of what the x is, it's just going to be a positive number, all right? But I got a negative number in front of me, so I say negative. Now let me see if I can do the sign now. What's it going to be? It's going to be sine of minus 60 degrees. And then it's going to be plus cosine of minus 60 degrees. And this is more complicated. There's no doubt about it, all right? So I know I got a negative number over here. It doesn't matter what the number is, it's a negative number. The sine of minus 60 degrees, if you think about it, let me put a triangle down for you. That would be root 3 over 2. And the sine of that would be, certainly minus 60 degrees to the left of the origin. And the sine function looks like this over here. So that would be minus root 3 over 2. Now let's look at the cosine. Now the cosine of minus 60 is going to be just 1/2. And why is that? Well, it looks like this over here. All right, it's in this quadrant over here. So I'm going to say, what does that give me? Well, minus root 3 plus 1 is a negative number. And a negative times a negative is a positive. All right, let me get my eraser out. I'm kind of done with this. I'm done with this business over here. And what I want to do is talk about what the question was. And this is just part A. Part A says, the critical values, what are they? I claim the critical values were minus pi over 12 and pi over 4. A local maximum occurs at minus 15. Okay, minus pi over 12. And a local minimum occurs right over here at pi over 4. Okay? So that's not so bad to do. And certainly that A is done. It took me time, but I got through A. What I want to do is I want to erase A, and I want to move on to B now. Now, my suspicion B is going to ask me about the second derivative. And the problem with the second derivative is I need to know the first derivative to have the second derivative. Do I know the first derivative? I do. Now, by the way, I'm making an assumption that's what it is. Let's read the question. Find the points of inflection. Yeah, they're asking for it. Let me start to erase this business over here, too. And let me go through the derivative now. So I want to write down f double prime. And again, I see a product. I see the first function times the second function. Well, let me take the derivative of the first function. What's that going to be? It's going to be 9 e to the minus 3x times cosine of 3x plus sine of 3x. Then it's going to be minus, because I'm actually adding on, but minus 3 e to the minus 3x times the derivative of the inside. And what's that going to be? I'm going to write in a little backwards form, but I'm going to take the derivative of this thing first. Cosine of 3x. I know there's a multiple of 3 there, so I'm going to factor that out. And, maybe I'll just put it down for the time being. I'm not going to factor it out yet. And then it'll be minus 3 sine 3x. And that's the derivative of this guy over here. I'm kind of looking at that, and I know there's some things going on here. I want to be very careful about it, though. I got 9 e to the minus 3x cosine 3x plus sine 3x. And this is going to be, I'm going to write down plus, and you may wonder what I'm doing, I'm going to factor out a minus 3 now, plus 9 e to the minus 3x. And then you would get, I factored out a minus 3, right? So I'd get sine of 3x minus cosine of 3x. All right? And then, I kind of factor out 9 e to the minus 3x here. And you'd have cosine 3x minus cosine 3x. They disappear. And then you get 2 of these guys over here. I'll write that down. I'm going to simplify that and write that as 18 e to the minus 3x times sine of 3x. All right. Now, certainly someone says, I wonder if I got that right. And, that's one thing that's bad having an answer key. You'll be able to verify that you got it right. And if you got it wrong, you probably want to correct yourself. So I got 18 e to the minus 3x sine 3x. I'm feeling pretty good about that. So what I'm going to do now is really the same thing. I'm looking for critical numbers along the path. And I want to remind you, our path starts at minus pi over 6. And it stops at pi over 2. I want to talk about the degree measure again. This is 90 degrees. And minus pi over 6. I'm going to write this down for you. We just did, I realized that. 180 degrees over pi. Pi's cancel off. 6 goes into 180, 30 degree times, so minus 30. That looks like 300. Minus 30 degrees. And that's a number line. Okay, what do you do now? Let me get my eraser out. Erase this business, erase that. I'm pretty satisfied I got the correct derivative, so I'm going to sort of erase this work over here too. And I'm trying to get rid of distractions at this point. And so I'm going to look at this and say, I'm really kind of looking at, when the derivative takes on a 0, because it's defined everywhere. So really what I'm looking at, when does the sine function take on a 0? And the sine function takes on a 0, let me make this when theta is equal to, let's see, pi, k. Or if you prefer 180 degrees, k. But what do I have? I don't have theta. I have 3x. And I'm going to use degree measure, but I will go back and convert it. So x would equal, 3 into 180 is 60 degree time. So I get some numbers over here. For example, you could choose 0. You get 0. I'll put that over here. You could choose minus 1, but you get minus 60, and that's below minus 30, so I wouldn't do that. And then I guess I could use 1. That would be 60 degrees. That's over here somewhere. I think you get the idea. I think I got them all. All right. Let me get my eraser out. I think I got them all listed. And they're the critical numbers. Critical numbers in radian measure would be 0. And 60 would be pi over 3. All right. What do I want to do? I want to kind of test the waters out. And again, I want to emphasize over here that the beginning part of the problem, regardless of what x is always going to be positive. So I'm really just analyzing the sign of the sine function on those intervals. So for example, if you took a number over here, and I'm just going to say like if you took 70, all right? What would you get? You would get the sine of 3 times 70, which is 210 degrees. And again, I want to kind of remind you, sine function looks like this over here. This is 180, this is 270. So I know that's negative. Or I'm not going to give you the number, but I know it's negative. So I'll put that down. Now, if I went over here and picked a number, and so I wonder what number you're going to pick. Any number you like, by the way. And what I'm going to pick is a number I like. I'm going to pick 10. 10 degrees. What do you get over there? Again, the beginning guy is e to some power, and that doesn't matter. It's always going to be positive. And then in the inside, what you get sine. Well, if I chose 10 degrees, it would be sine of 30 degrees. I certainly know that's positive. Increasing, decreasing for the function. I'm sorry. This is this is second derivative. I'm sorry. Let me get my go backwards on that. This is concave up. I just did it again. Sorry. This is concave up. This is concave down. Let me go over here, and I'm going to pick minus 10 degrees. All right? Let's go back over here. And again, I know 18 e to some power is always going to be positive. Then I get sine of minus 30 degrees. And, you know, like if you thought about sine of minus 30 degrees is definitely going to be negative. So you can get positive times a negative, which is negative. That means it's concave down. So I got 2 points of inflection now, all right? 2 points. The points of inflection occur when x equals 0. I'll write that in radian. And the other point of inflection is when x equals pi over 3. All right? So let's see if we got that. And again, I'm reading in the key. Occur at 0, pi over 3. Again, I'm going to say, you know, concave down. It's concave down here between minus pi over 6 and 0. And it's also concave down between pi over 3 and pi over 2. All right? It's concave up over here, and that's 0 to pi over 3. Thank you.